Hello everyone. Today we are going to start a new topic on the fluid mechanics. We will be deriving the Euler's equation of motion. We will understand how the Euler equation is derived, and after that we will gonna learn how we can get the Bernoulli's equation from the Euler's equation of motion. So first of all, let's start with the basics. So from the basic, if we start from the basic, that from Newton's law of motion, we know that F is equal to ma. So force equals to mass multiplied by the acceleration. Okay. So if we want to express the sorry, if we want to express the force acted on a fluid or acted on a flowing fluid, then let's assume, or let's just write down the forces. So the first force will be force due to pressure. Force due to pressure. As the fluid flows, a pressure builds up, so that will be F of P, force build up due to the pressure. Okay, after that, force due to velocity. Velocity, that will be F of V. Okay, after that, force developed due to the virtue of gravity. Gravity, that will be F of G. After that comes the force due to turbulence. Force due to turbulence, that will be F of T. Okay, then after that, a last type of force will build up on it, that will be due to the fluid's compressibility. Compressibility, that will be F of C. We all know that liquids are incompressible fluid and air are compressible fluid. Also, there are some type of fluid, those are on the middle of this two. So okay, well, if we just use the equation form to determine this, or to showcast this, then it will be F of P, force due to pressure, plus F of V, force due to velocity, plus F of G, force due to gravitational force, and then the force build up for turbulence, and finally the force due to compressibility will be equal to the mass of the fluid and the acceleration of the fluid. So this part can also be said as the summation of all the forces. Okay, equals to, we know that, ma this side. Okay, after that, what we're gonna do after that, let's do some assumptions. So for the first assumption 1, okay, so for the first assumption, let's assume that the the fluid which we are dealing with is a liquid. So if it's liquid, then the compressibility, or F of C, will be 0. Okay, so this term will become 0. Okay, after that, if we also assume that the force due to the turbulence, developed due to the turbulence, will be also 0. Okay, so it's like the flow is a laminar flow, and as there is no turbulence, the force build up due to turbulence will also be 0. So due after that we can write it as f of p plus f of v plus f of g equals to m a x. Well, congratulations, we have derived the, okay, one sec. Okay, so we have okay, so this is the equation, and this equation is actually called as Navier-Stokes equation. Okay. Okay, so let me change it. Navier-Stokes equation. Navier-Stokes equation. So the equation actually looks very much easy terms, that only the pressure, the velocity, and the gravitational force are acting on it to make the Navier-Stokes equation. But the actual Navier-Stokes equation is actually much more difficult and much more complex than the simplified version of this. Well, it is not impossible to understand, or it is not that much hard or anything. It is just uh, the assumptions are a bit more complex, but we can understand it if we try to. So that's it. And you never know what is your limit until you encounter it. Okay, so let's go to the assumption 2. So in the assumption 2, what will we assume? We will assume that the flow is laminar flow. So as it is okay, so sorry, it's laminar flow we have assumed over here. So we will assume that the velocity, the oh, okay, so I think we have messed up in one point. So one second. This term, this will be viscosity, not velocity. Sorry. This term will be viscosity. This term will be viscosity. That whole term will be viscosity. Force due to viscosity, and then we'll get this, and we'll now assume that the viscosity is 0, and the viscosity is 0 in the case of ideal fluid. Okay, in the case of ideal fluid, and for this condition we're gonna now get the final equation, that will be f of p plus f of g, which will be equal to m of a. So this is it, and as we get over here, it is the Euler's equation of motion, or we can say that it is the Euler equation. Okay, so now we're gonna derive it. Okay, so now what we're gonna do, we're gonna just derive the equation, and for deriving the equation we're gonna assume some points. Okay, so let's assume over here, so let's assume that this is a pipe, this is a pipe, and this is a pipe, and this is the cross section. Okay, so this is the cross section, and along the cross section we're gonna just uh, take a streamline. just uh, just look at like this is a streamline, this is a streamline. So I think that all of you know that what is streamline. So streamline is basically one kind of guiding or a guidance of the fluid flowing, so that the guide or the flow remains laminar and the flow actually can be guided easily like that. So in the uh, in the case of aerodynamics, these structures are called streamlined, as the air passing through are guided by the structure. So these are getting guided. So in that way, this is streamlined. Okay, so after that, let's assume some more points. So let's assume that here there is a pressure. Pressure is applicable over here, and yeah, over here there is also a pressure. So for this, let's just imagine, okay, sorry, let's just determine the F. So the F will be, F is equal to ma. Again, we know that F is equal to pa. Okay, and p is equal to f by a. So pa, but as we are considering it a very small portion, this is the ds, and the as then as the area will be dA, so it will be p dA. Okay, and after that, if we uh, just get over here, then the pressure or the pressure force against this pressure, we're gonna get p plus del p. One second, let me just, del p by del s ds into dA. So this is the form. And now if we just one thing that, okay, so here this one will be, if we just imagine this, so this one, if we imagine it as mg or w, so the weight of it will be acting downward, as the gravitational force is not zero. So in that case, if we just change the value of the m, or we can get pv to g, right? Okay, so if we change this further, sorry, it's rho vg. So if we change this further, we'll get rho g multiplied by dA into ds, right? Okay. So, and if we take this angle theta, then if we use the uh, sine rule, or if we use the vector rule, we're gonna get that this will be rho dA ds into g cos theta. Well, these are the things that we have determined. This one. Then after that, what we have done, we have this also. Also, we have this. Okay. So using these equations, we are going to actually determine the thing. Actually, okay, we are going to determine it. Okay, so now we're gonna have is a little bit down. Okay, so if we want to write the equation, so the equation will be p d of a minus p plus dp by ds multiplied ds into dA, okay, minus rho g dA ds cos theta. Okay, okay, so it will be equal to ma. So as in now we are going to write again rho dA ds, and then as. For your understanding, I'm just going to highlight this portion. So this is actually MA, this is the M, and this is AS. So in with respect to this we have written this part. Okay, so I need to erase it for reducing the reducing the confusion. Okay, so let's go further. So if we go further, then we're gonna see that this part and this part will be cancelled. We'll get this part, and after that we're gonna just divide the equations. Okay, so let's move forward. We're gonna get rho p by rho s ds dA, right, minus rho g dA ds cos theta equal to rho dA ds as. Okay, so after further simplification we're gonna get rho p by del p by del s minus we're gonna get rho g cos theta equal to the rho as. Okay, so we're gonna get this. Okay, so after that if we just furthermore simplification, we're gonna get del p by del p by rho g. Okay, del p by rho g, and then what we're gonna get is del p by rho g, and then over here we're gonna get cos theta equals to as by rho g, right? Okay, but okay, so here it will be rho, and the rho will be gone, so we're gonna get only the g. Okay, okay, so let now consider the cos theta. So in the case of cos theta, if we just determine that this is the height. Okay, so just imagine that this is the height, and as such this is z, this is the datum head, we can imagine, and this one, this is the s. So the datum head, let dz, and the this cross section, this is ds. So from that we can write write actually in the place of cos theta we can write that cos theta equals to cos theta will be equal to the dz divided by ds. Okay, so it will be dz divided by ds. Okay, so sorry for the handwriting. Okay, dz by ds. Then after that what we're gonna get this thing, and as the term ds, so the ds term will get get cancelled out. Also there is also a ds. So what we are getting del p by rho g. Okay, then minus dz, let dz, right, we're gonna get 1 by g as. Yes. Okay, so in the form of as, so we can actually write for as is, let's just as is a function of displacement and time. Okay, so as it is a function of displacement and time, we can write it as as equals to del v by dv by dt, that is dv by dt. So dv by dt is the local acceleration, and with that we're gonna get another acceleration that will be del v by del t into, sorry, dv by ds equals to ds by dt. So these are the things, and after that as we have assumed that it is a stream, sorry, as uh, it is a flow of laminar, and it is a flow where the velocity does not change with respect to time, so this portion will be 0. And we have then moved along with this part, this portion. So this portion, uh, for this part, what we're gonna get, we're gonna get v multiplied by, for this it will be dv by ds. So from moving forward, let's write. So we're gonna get del p by rho g minus dz equals to 1 by g multiplied by, we're gonna get v dv. Okay, so as we are getting v dv, okay. Okay, so as we're getting vdv, then okay, so we have derived the equation. Okay, so this is the equation, and this equation actually refers to the Euler's equation of motion. Okay, Euler's equation of motion. Okay, so Euler's equation of motion, and now what we're gonna do is just integrate it to get the equation for Bernoulli equation. So if we just integrate this part, we're gonna get minus p divided by rho g minus z and minus v square by 2g, okay, v square by 2g, and it will be equal to a constant. Okay, so as we just remove the minuses, we're gonna get this equation. So here, this part, sorry, here this part is the pressure head, known as the pressure head, and this part is known as the datum head, and after that this part is known as the velocity or kinetic energy equals to the constant. So this is actually the Bernoulli's equation. So this is actually the Bernoulli's equation of motion, or we can say that no motion, but it is actually Bernoulli's equation. Okay, so Bernoulli's equation, and to determine this, what we have assumed, let's just write the assumptions that we have made. Okay, so I hope it is visible. Okay, so what assumptions we have made. So at first we have assumed that the flow, okay, so at first we have assumed that the fluid is in viscous, or we can say it as in viscid. Okay, so in viscous or in viscid, we can say it that. Okay, in viscous or in viscid. Okay, so in viscous and in viscid. Then after that, what we have assumed, we have assumed that the fluid is actually incompressible. incompressible. Then after that, what we have assumed, after that we have assumed that it is in a steady flow, and it is actually in uniform flow at the uh, section line, as we assumed. And after that, well, these are the assumptions that we have made so far to determine this equation. And further that we have further that we have also, like, yeah, these are the assumptions that we have made so far and discussed. Steady flow, well, there is another one, sorry. So this one, the flow is a steady steady flow. So that's all for today, and hope you guys have understood. Please don't forget to subscribe and tell me if you have any queries. I'll try to solve it. So thank you, Sayonara. Thank you, Sayonara. Tata. See ya.